And the falling stars, are they the dead stars?
They've got nothing to do with stars.
Nothing
They're
to
just
do.
bits of leftover rock and debris from comets and asteroids.
Right.
So the space station's made is the size of a football field. It's 110 metres long. It's
Really?
quite big. And it has different sections for the different countries and that are up there.
I'm Faye, and this is Conversations with Faye. Today, to come from much more. Let's find out what's going on.
I'm going to put it on the page.
Conversations with Faye, changing lives, one conversation at a time. Welcome back. I have Donna Burton, who is more affectionately known as Donna the Astronomer. And today we're going to be talking about space debris. What do you mean by space debris?
Well, since 1957 when Sputnik went up, things have been going up into space quite frequently. And
what do you mean? What sort of things going up into space?
Satellites, spacecraft, bits of rockets as they've been testing things from different countries.
Right.
And have you ever thought about what happens to them?
No.
Well, some stay up there. There's still bits of rocket up there from bits of rocket stages up there and satellites since the 1950s and the early 60s still.
It's still floating around.
Still floating around. And, of course, we're putting up more and more satellites. I mean, yesterday, SpaceX launched at least 48 more satellites. They did 2 launches yesterday.
48 satellites. And why are they sending all these satellites up into the sky?
Well, in the case of Starlink and in the case of what China's doing at the moment as well, because they're putting up their own constellation, and the 2 other major companies in the world putting up these constellations of satellites that are going to orbit around the place. And these are to give us all internet. I mean, China's is solely so that they have to use the Chinese one so they can't get access to the rest of the world. Things. But so they're in low Earth orbit and they don't always make it. I mean, a couple of months ago, a Chinese spacecraft blew up in space and all the debris is still there.
So it's floating around. Will it ever drop down to Earth again?
There are easily over 30, 40, 50,000 bits of space debris and satellites up there. And they pose problems to the International Space Station and to, how we're planning to send people to the moon and the Artemis mission and obviously to Mars ultimately. And when you've got these space launches and everything else, they've got to get through this debris field.
Right.
And that can be from 150 kilometres above the Earth to 600 or more. I mean, geostationary satellites are at over 30,000 kilometres above the Earth. But all these other satellites are anywhere between 150 and 600 kilometres. And they're basically set up to cover the whole of the Earth to provide internet communications. And, of course, you've got all your other satellites that we have no idea what they're doing, the defence satellites, the weather satellites, space satellites looking at space for good purposes as well. But they crash into each other. Several years ago, a Russian rocket stage that was out of control crashed into an Iridium communication satellite owned by the US. It made thousands of pieces of debris.
But did any of it come to Earth?
Some comes back to Earth. So sometimes you see meteors. In fact, there was a big one down here the last week or so that was part of the satellite returning to the Earth. Often it's actual space debris from asteroids and comets and things like that. Most meteor showers, like the ones coming this month and in November and December, are from comets and asteroids, so they're normal. But this other debris comes in quite frequently, and that can be bits like the size of a grain of sand.
Really?
Up to big chunky bits.
What damage do they do? I mean, they'd be coming at a rather big speed.
They do. Most of them burn up in our atmosphere. They don't actually contact the Earth.
Right, okay.
When they deliberately bring satellites down on purpose, they have a place off the west coast of South America, a big trench there, that we call the satellite graveyard. But, of course, you think of the older satellites, the older rocket stages and that from Russia and from everywhere, basically. The fuel and everything else that was in them, the other things that are in them are very not exactly good for the environment. Is that a practical way of saying it?
What's a meteor? Please explain.
Okay. So you have 3 stages. So you have a meteoroid,
Meteoroid.
And they're the things that are floating in space. They could be size of grain of sand up to bits of rock and that have come off comets or off asteroids that have passed through the Earth's orbit as they go around the sun. And then the Earth's atmosphere hits them and they burn up, and that's when they become meteors. And they're what you call shooting or falling stars.
Right.
And then when they actually land on the ground, they're called meteorites.
Right.
And unfortunately, the government owns them when they hit the ground because they belong to science.
Oh, really? Okay. So nobody can claim them if it falls on their land or anything like that. What size would they be?
Well, they can be quite from the size of your fist to the size of the thumbnail. So they could be a bit bigger.
They wouldn't be easy to find if they landed on farmland or something like that.
You
unless
normally
you
find
knew.
them. Yeah, the Nullarbor, Antarctica, that's where they're most prominent, and deserts because they're different colours, so they stand out against the background.
Right. Okay.
But these days there are a lot of tracking cameras. We've got watches. We've got plenty of where we're watching for meteors, and we can triangulate where they land and things like that.
Right. So when you say watches, it's not a watch on your wrist.
Cameras.
It's cameras that are watching the night skies and watching what's going on in the night sky.
For fireballs. There's a whole fireball society of people across the country who are tracking fireballs, which are the really bigger meteors that you see.
Right.
The really bright ones.
So the human eye would miss it if you didn't know what you were looking for.
You see the flashes in the sky,
right?
Have you ever seen a shooting star or falling star?
Oh, yes, I have.
Yeah,
yes,
yeah. And obviously they're much easier to see.
Did you say you wish upon a falling star
or catch a falling star? Catch it in your pocket.
Yes,
not a good idea because it'll burn a hole. But probably not a good idea.
And the falling stars, are they the dead stars?
They've got nothing to do with stars.
Nothing to do
bits of leftover rock and debris from comets and asteroids. If a star fell on us, we'd be in deep trouble.
Oh, yes, because they're quite large.
And you put 1.3 million Earths inside the sun.
Right. Okay.
So do you really want that to fall on us?
No, I don't. No, thank you. So meteorites, they are, when they're floating in the sky, what are they called again?
Meteoroids.
Meteoroids. When they fall to land, they're called meteorites.
When they're burning up, they're called meteors. And when they land, they're called meteorites.
Oh, God. That's all confusing. Why can't they just call it one thing and be done with it?
Because they're different stages, like ice, water, and steam.
Oh, right. Okay, that makes sense.
Yeah.
That makes sense. What other pollutions in the sky that we don't even know about?
So we have the natural things from the comets, the natural I've got me calling falling stars now, the natural rocks and things that are up there, space debris. But then, of course, we've got the debris from these satellites.
Right.
Several years ago, China crashed 2 satellites together to see what would happen.
They deliberately did it.
They deliberately did it. More space debris. The Indian, from the election before last, they decided to shoot down one of their satellites to show their missile capabilities. More space debris. And so...
Did it fall to Earth or did it just shatter? And
they stay up there and eventually they'll come back to Earth as they deorbit. I mean, you might have been listening in the news about the space station, the International Space Station.
No.
So there's been 2 stories lately. One is about, there's been a leak for 5 years in the Russian part.
Right.
So the space station's is the size of a football field. It's 110 metres long.
Really?
It's quite big. And it has different sections for the different countries and that are up there in the labs and everything else. But in the Russians, been obviously hit at some time by a small meteoroid, or we call a micro meteorite. And it's basically hit the thing and it's made a leak. And they haven't been able to find. Now, this happens occasionally and they fix them up and they can find and they fix it up. I think the movie Gravity, the only true thing in that is that there is a space station and they can be hit by space debris. Happens every 96 minutes or so. But it was a very good movie.
Yeah.
You don't believe it all. But that's the premise of that, is a meteor hit the space station and then they had to escape from there. And it's a big problem.
How dangerous is it?
For you sitting down here on Earth, very few people on Earth have ever been hit by a meteor.
Yeah, well, has anyone?
Yeah, I believe there was a person in China who they got their thumb burnt and got hit by one on their thumb. I mean, you'd have to be pretty lucky to get your thumb hit. A lady in New Zealand was sleeping in her bed and one came through a roof and landed on her bed and burnt her side, but she was fine.
That would have been a larger one, but the
Yeah, that
force
was
of
about the size of a fist.
the size of it and the force,
It
the
was a lot
speed.
bigger when it started.
Yeah.
Oh, by the time they're getting down here, they're not travelling that fast. But then you get the big ones like the Henbury meteor that formed, or the craters like formed at Wolfe Creek and all
Yeah.
those places.
Yeah.
They were really big ones.
Yeah.
The one that wiped out the dinosaur was pretty big in the Gulf of Mexico.
Yeah.
So they're big things. So we call them dinosaur killers, and we spend a lot of time protecting the Earth from those and looking for them. But the smaller amounts, there's about 40,000 pieces of debris, both natural and man-made, that are being monitored because of the risk to space stations and spaceflight.
Wow.
If you were out last night, after the launch of the Starlink ones, you'd see the beautiful, there was like, I call it a freight train, other people call it a string of pearls, but you had like a long line of the satellites as they were going into their orbit. So they were released and they're like that, and over the next few nights they'll get further and further apart. Now, from the point of view of if you're in a dark sky, which is probably not likely to see in your backyard here,
Yeah.
but they are really interesting to watch. And I mean, I think one night show we had without Starlink, we saw 50 satellites in
50?
1.5 hours of our night show.
Wow.
And there are hundreds up there now. Obviously, we're in a dark sky, so we see them better.
Right.
But if you can find a spot to just go lying down and look up, you're going to see natural meteorites at the moment, except for the moons out there. But there's sporadic meteorites, but there's a meteor shower. You'll see more meteors per hour during the meteor shower than you will normally. And then you have all the other stuff that's up there.
How do you know when there's a meteor shower coming?
So basically, comets and asteroids go around the sun, just like we do. And they're pretty predictable. So we know where they are and we know where they leave their debris. And so the Earth's atmosphere, as the Earth's going around in its orbit, remember it's not circular, it's elliptical.
Mm.
So it hits them at certain times of the year.
All right.
So the 17th is the peak of the Leonid meteor shower, which is this month. And then next month it's the Gemini meteor shower.
So what was the first meteor shower?
The Leonids, because it appears to come out of the constellation of Leo.
Oh, right. Okay.
In the early morning, but that's where it appears to radiate from, but it's not really anywhere near the constellation or the stars because it's in our Earth's atmosphere.
Right.
As we're in our Earth's orbit around the sun, so it's very close.
Right.
And the Geminids are in the constellation of Gemini, appear to come from the constellation of Gemini.
Right.
And we can predict when they are, so they come from different comets. So,
wow, this is fascinating.
But that's natural. And that's been happening since time immemorial.
I have to ask, and it's a little bit off topic. Who was the first astronomer?
Well, arguably, probably Indigenous Australians.
Indigenous Australians.
Because the Indigenous Australians have had like a culture that goes back for tens of thousands of years that weren't impacted by various other civilizations like other countries were.
And they used the stars.
They used the stars
to travel because there was nothing else to use.
They have songlines which help them go by. They use the stars when they rise and set for moving on. They use the emu in the sky, which is using as a dark constellation, using the dark spaces, would tell them when to move back to different parts of the country to be able to harvest emu eggs and things like that, and when to move because the weather was coming. They were very good also at predicting weather by the stars.
Right.
And so the only reason I say that, of course, you've got your Babylonians, your Chaldeans, and the people before that, but we don't have the recording. But because the Indigenous Australians have been here for so long, and of course the Polynesians as well, since 3000 BC.
Right.
So you've got the cultures that haven't been touched until colonisation. Whereas if you think about Babylonia and Europe, they were constantly being taken over, the different empires from history at school.
Right.
So the information was lost. Now, we don't have a written, and the Indigenous people, both of Polynesia and Australia, don't have a written language, or from the Mayans and the Incas as well. You don't have a written language, but you did have the oral traditions. And so a lot's been lost because of in other countries, like when the Mayans and the Incans were wiped out, you've got the records. But we've still got the stories in both Polynesia and Indigenous Australians today.
And those stories would be absolutely fascinating.
Yeah, and they use this guy to help understand the laws. For example, we're talking about meteors and meteor showers. So they were seen as what's up there is down here. So they were the ancestors having a bite and throwing spears for meteor showers. So if you saw like 1,000 meteors in 15 or 20 minutes, which you certainly have been able to do at different times, 1966 was a really good one.
Right.
And then there was another one in the early 2000s where there were hundreds of meteors in a short period of time.
Right. Okay.
And so you can understand how people who didn't understand would see them as being spears being thrown. You know, the auroras that you see.
Oh,
they've
magnificent.
been being recorded throughout history right around the world. In most cultures, they're seen as bad things.
The
As fire in the
auroras.
sky, as fire in the sky. In some cultures in Australia, it's for breaking taboo. So you've eaten something you shouldn't eat, or you've married someone you shouldn't marry, you know, things like that.
Right.
And different things. So it's seen as people are being punished because they didn't understand it. And in 1859, there was a big event called the Carrington event. It was a big solar flare that happened. It was the first one recorded in modern history. There's been plenty of them before that, but they weren't recorded. But this one
What a
also had
shame.
a comet at the same time. And then Indigenous people in South Australia, because we've had people recording history and by 1859, went on walkabout and were feared and thought it was the ancestors getting back at the whitefellas for what they'd done. Because you had a comet, which is a harbinger of doom in just about every culture. See comets as bad things.
Why do they see comets?
I mean, didn't you know Pope Leo actually excommunicated Halley's Comet centuries ago for the Black Death?
No.
Oh, and you don't know about the comet that got the blame for
No, tell me about
lice that was being blamed for COVID?
No.
There was a comet visible just before COVID.
Oh,
And see what the Black Death was why Pope Leo got excommunicated Halley's Comet, because there's superstitions and everything else.
Around them.
They're rare events in the scheme of things. And if they coincide with things, I mean, many comets have coincided with battles, like the Battle of Hastings
Yes.
in 1066 when the king got killed.
Right. So explain exactly what a comet is, Donna.
So a comet is an object that can normally come from out past Pluto, but they come from out past Neptune, trans-Neptunian area, the Kuiper Belt or the Oort Cloud, which is even further out. Or they can be, like one of the comets I've discovered is between Mars and Jupiter.
Right.
And it comes around. But these objects we call them dirty snowballs.
Dirty snowballs.
Because
Why?
they rock and they're ice.
Oh, really?
And they travel around the sun. The most famous, of course, Halley's comes back, has been coming for many years.
Every 75,
76 years.
Mm.
And it was one of the first they were able to predict its return. And
Right.
it was Edmund Halley who predicted its return, who it's named after. But they've been able to track it back right through to, a few hundred years BC and even 1,000 or more years BC. And so they travel around the sun in a very elliptical orbit.
Right.
We go around the sun in a kind of regular elliptical orbit.
Yeah.
But these are like super elliptical. And like I said, one of my comets comes back every 30 and a bit years because it's only between Jupiter and here. And the other one's 28,000 years before it's going to come back.
All right. Well, I'm going to stop you right there because you are the first woman in Australia to discover 2 comets.
Yes, but that's only because I'm the one looking.
You were the one looking. But when
it's
did you...
It's not sexy science, you see.
Well, I think it is sexy science. So tell us about the first one you discovered and how did you find it?
Well, I was working on the Near Earth Object Survey at the Outside Telescope at Sighting Spring, which we're working in conjunction with fellows in Arizona. So we're basically playing Bruce Willis, protecting us from that asteroid. So the actual project, it was actually looking for near Earth asteroids. So that one that none of us want to be the one who finds, the next dinosaur killer.
All right.
Because that's part of the program is to protect us against those things and to record them all. And we, it pretty well keeps on going and it's sort of important. But along the way, of course, you find comets and things like that. And I was just lucky enough to find 2.
So what was the first comet and what's the name of it?
It's a very boring name. It's now called 386P sighting spring.
386P sighting springs.
It's
Why
original
couldn't you
name.
call your name?
Well, because I was working for the survey. I was being a little bit naughty at the time.
What a shame.
But that's all right. I know it's mine. Wikipedia knows it's mine. Google knows it's mine.
That's fantastic. What was the second one, and when did you discover that one?
The first one was in 2006. The second was in 2007, and it's got a really boring name. This is the one that won't come back for 28,000 years or so.
28,000 years. Well, you were lucky.
Well, yes, because the comet that's just been visible, the double-named atlas, Tishushan Atlas.
Tishushan Atlas.
Yeah, the one that's just been around. Tishushan means Purple Mountain. It's the name of the observatory in China.
Right.
In Mandarin, but since I don't speak Mandarin very well, I think Purple Mountain Atlas would sound better, but the observatory is called Tongjinshan.
Yeah.
That one won't come back for 80,000 years.
Wow. So the one that the second one that you discovered in 2007.
Yes.
What's it called?
2007 Q3 sighting spring.
Oh, Q3 sighting springs.
But it's a comet, but it's also broken up.
Oh.
It broke up into pieces, so it was actually seen by some other people, and that made it even more interesting.
Right.
So it had multiple components in its head.
Wow. Wow. Do you have photos of these comets?
Unfortunately, the ABC has one of the comet, because the first comet I discovered was actually NASA's WISE mission took a photo of it because it's an infrared mission, and comets are cool, literally, as well as figuratively, in temperature. And so it took a picture of the comet and was the first picture it released.
Wow.
So
is that available?
Yes, on the ABC, yeah. You can just Google. And Google Donna Burton and comet, and it actually comes up, would you believe?
Okay, well, we will. And what was the second comet? Is there a photo of that or not?
Only my discovery photos, and they're really sort of boring to most people. They're sort of like multiple pictures, and you just see this little dot going across the screen.
Oh, I would love to see that. Yes. All right. What else can you tell us about the comets and the debris in the night sky?
So there's just, so again, if you can get to a place where it's dark and you can just lay down and let your eyes adjust again, but spend an hour or so out there and you'll see your satellites and your things, and you'll see sporadic meteors, which means they're not part of a meteor shower. Like the next two meteor showers, unfortunately, the moon's going to be a problem.
Because it will be too bright?
The moon's at like tonight's the full moon.
Yeah.
The full moon was a little bit earlier today, and the shower and the peak is on the 17th.
Right.
Today, the 16th.
Yeah.
So tomorrow night.
Yeah.
All the early hours of the morning.
Mm.
So the moon will impact it. So it means you can't see, but some of the fireballs are quite bright. So even in the city, if you can get somewhere
where it's reasonably dark,
and has to be in the early hours of the morning.
Yeah. So what sort of roughly 2-3 o'clock?
Yeah. Up until dawn. Yeah.
Yeah. Okay. Anything else you can tell us about the debris in?
Yeah. So it is seriously a really major problem.
Is there any way they can clean it up?
So they have lots of ideas, and I have to confess that many years ago, at least 20, again last century probably. You think that's really funny? It's making me feel old talking about it. You talk about these things. Older, yeah. So you talk about these things, and so I said, we need a vacuum cleaner. We need an electromagnetic vacuum cleaner in space.
Electromagnetic vacuum?
Well, yeah, so basically you turn the magnet on, spin something up, and the magnet collects the things and you dump it back in. And everybody just laughed at me, as they do, because it did, it does sound really silly. But now that's the sort of thing they're doing. They're designing equipment to go up there and clean up this debris using a robotic arm that will go out and collect the debris, put it back into the thing, bring it back to Earth and dispose of it. Well, I was just ahead of my time.
Ahead of your time. Well, you know what? It's quite interesting to have these conversations with you, Donna, because, I learned so much, and hopefully the viewers will learn lots and want to know more, because I find the more I learn about the night sky, the more I want to know about it. It's not that I'll ever know much about it because there's so much to know, but there's a lot of history there. There's a lot of, you don't even think about the debris unless you're a scientist and you're dealing with the night sky and the all the satellites and the comets and everything else, you don't understand it. I mean, you've got people going to the moon now. They're going to the moon, but do they understand what the atmosphere around the moon and everything else is?
And the pollution we've done on other planets.
Yes.
All the stuff we put on Mars. We've crashed things into Titan, Saturn's moons. We've crashed things into Saturn, to Jupiter, to Mercury. Plenty into Venus as well. And we have spacecraft out beyond the edge of our solar system. And who knows what they're carrying.
How do you know there's spacecraft out beyond the solar system?
Voyager.
Oh, Voyager.
The two Voyagers.
Yeah.
And, of course, Pioneer, Mariner, once we lost contact with them, if they're still on their tracks.
Okay, and they'll be out there forever.
They'll be out there forever. Long after we're gone.
Wow. Wow, that's very fascinating. So what would you say to the viewers about understanding when they look up and they see the comets and the debris or the meteors dropping from the sky or dropping into Earth? They can be as small as a grain of sand. They can be as big as a fist.
Or bigger than that, they can be bigger than your head.
Yeah.
And sometimes they're like they're like the ones that are like the size of a small, big rocks, and they're the ones that tend to land as they don't all burn up. But most of them burn up in our atmosphere.
Are there
and that's what you're seeing.
Are there any in museums or anything like that?
Well, I was just down in Adelaide, and I went to the Adelaide Museum because I knew I thought they had a particular meteorite, but they didn't. They had other meteorites. They had the Murchison meteorite plus many other meteorites down there. There's so many in South Australia, so many meteor craters. There's Henbury, Wolfe Creek, which we all know because of scary movies. There's Tanola, which is Goss's Bluff. So there are many, many meteor craters.
Okay.
There.
Yeah. Be interesting to look at and just have a better understanding of.
Well, they found a meteorite in Antarctica in the Allen Hills, which they believed for a while. They know it's from Mars, that's the fact, but they believed for a while that there was evidence of fossilized bacteria in it. And it's still questionable whether there is or not. Right. It's not completely disproven.
Okay.
And that came from Mars.
Okay. All right. That leaves a lot of room for thought.
It does.
Thank you, Donna, for another amazing conversation. I'm Faye Waterman. This has been Conversations with Faye and Donna Burton, who is more affectionately known as Donna the Astronomer, with a wealth of knowledge. And I'm going to bring her back for some more shows because I think what she has to say is very, very interesting and important for us to understand. Thank you, Donna.
Thank you, Faye.
Hit the subscribe button on our YouTube channel, like us on Facebook, and follow us on Instagram. Changing lives, one conversation at a time.